Hey everybody, so today we're going to learn about proportional relationships. So you're going to need your spiral, a calculator, a pencil, and the graph paper that I gave you in class. So why are we learning about this? Well, proportional relationships are always around us. They are used in many things like cooking, chemical mixtures, medicine, shopping, and those are just a couple of examples where proportional relationships are. So what are they? It's the relationship between inputs and outputs in which the ratio of inputs and outputs are always the same. If the relationship is in a table, you can write the ratio of each input to its corresponding output, and if the ratios are the same, then the relationship is proportional. And we're going to look at exactly what this means. So you want to make sure you write down what a proportional relationship is. So what does that mean? So this is always our input, and this is our output. So the slide before said the definition of a proportional relationship is the input to the output in a ratio. So I'm going to take my input, which is 1, and the output is 50, and I'm going to write it as a ratio. Then my next ratio, the input of 2, and the output of 100. Well, I always want to simplify, so I can divide the top and bottom both by 2, and I'll get 1 over 50. So let's take the next one, 3 over 150. Again, I want to simplify, so divide the top by 3, the bottom by 3, and we get 1 to 50. And the last one, 4 to 240. So I'm just taking the input and putting over its corresponding output. So if I divide the top and bottom by 4, I'm going to get 1 over 60. These are our ratios because they're all simplified. Well, they are not all the same. 150, 150, 150, and then 1 to 60. So because this last one is not the same, this is not a proportional relationship. So it's very important that you put all of your input and output values in a ratio and simplify, because you could get to the last one to see that it is not proportional. So let's look at the next one. Just tomato prices. So 2 pounds for $3, 4 pounds for $6, 6 pounds for $9. I'm going to take my input and put it over my output. And that is simplified. Then I'm going to take my input of 4, the output of 6. I can simplify this by dividing the top and bottom by 2, so I get 2 to 3. 6 to 9, and again I can simplify it by dividing by 3, and I get 2 to 3. So because all of our ratios simplified are the same, this relationship is proportional. So let's look at another one. This pizza slices are selling as follows: 1 for $2, 2 for $3, and 4 for $5. So again, my input 1 to 2, that's simplified, 2 to 3, that's simplified, and 4 to 5, that's simplified. Well, since these are all simplified and they are not the same, this is not proportional. So this would not be a proportional relationship. This says the ratios of all the inputs to outputs in a table are 1 to 4. So if we simplified all of the inputs to outputs like we've done on the past slide, and we get 1 to 4, would the relationship be proportional? Yes, it would. Because they're all 1 to 4. go ahead and try these two on your own. And again, you want to put your input over your output and simplify. So for this one, we're going to have 15 to 4. We want to leave it improper. Don't switch it to a mix. You can go ahead and simplify the rest and try this one. So for Karina's bike trip, I took 15 to 4, then I put 30 to 8, divided the top and bottom by 2 to get 15 to 4. Then I had 45 to 12, so I divided the top and bottom by 3 to get 15 to 4. And then 60 to 16, divided the top and bottom by 4. So all of the ratios are the same. So yes, this is a proportional relationship. Here I put 1 to 1, 3 to 2, and 5 to 3. They are all simplified and they are not the same, so it's not a proportional relationship. So here we can make a table and then make a graph from our table. So it says Jenna earns $12 per hour making bracelets. She uses the function E equals 12 times H to track her earning, where E represents her earning and H represents the number of hours. So we're going to make an input-output table, and then we're going to graph our results. So you're going to need your graph paper. Then we want to know, does this function have a proportional relationship? So we're just going to plug in the numbers 1, 2, 3, and 4. So our input is our H. So I'm going to take 1, plug that in. So 12 times 1 is 12. Then I'm going to take 2, plug that in. 12 times 2 is 24. Then I'm going to take 3, plug that in. 12 times 3 is 36. And then take 4, plug it in. 12 times 4 is 48. So for 1 hour, she earns $12. 2 hours, she earns 24. 3 hours, she earns 36. 4 hours, she earns 48. So now, let's look at our graph paper. I'm going to take this chart and copy it. To the next page. So you have your chart in front of you, and I just want us to be able to see it while we graph. So I first have to label my axes. You always have to do that. So we can just call this Jenna's earning. Hours worked is our input. That goes on the X. The earnings is the output. That goes on the Y. So I'm going to start at 0. I know I have to go up to 4, so I'm going to skip a line 1, skip a line, skip a line 2, skip a line 3, skip a line 4. Then I'm going from 12 to 48. So you can determine what interval you want to go up at. You can go by 2, you can go by 10, you can go by 5, you can go by 12, whatever will help you to see. You always want to make sure how many lines you have. If I start going 2, 4, 6, 8, 10, 12, I might not have enough to get all the way to 48. So I'm going to just go by 5s today. So 0, I'm going to put skip a line, and we'll skip a line here. Put 0, 5, and the next like 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So now I'm going to plot. So this is my ordered pair, 1, 12. If I were to rewrite that as an ordered pair, it would look like this. And I graph just like I do on my axes. So I go over to 1, and then I go up to 12, put a dot. Then I go to 2, go up to 24, put a dot. 3, go up to 36, put a dot. 4 go up to 48 and put a dot. Now we're going to connect. Look at 0 hours means $0. So draw a line. And we're going to see that this is a proportional relationship that extends into a straight line. So let's look at the next one. It says the function t equals 4 times m gives the temperature T in degrees Celsius after m number of minutes of a liquid during a science. So we want to know, does it have a proportional relationship? So my input m, my output is 2. I'm going to use 1, 2, 3, 4. Your input, it will either tell you or we're just going to use 1 through 4 if it doesn't tell you. So that's where I'm getting these numbers from. So now I want you to go ahead, plug in our inputs to figure out our outputs. Don't go on to the graph yet. Just try the numbers and plug them into the table. So you should have gotten 4, 8, 12, and 16 because you're plugging in 1 times 4, 2 times 4, 3 times 4, 4 times 4. So now I want you to go ahead and make a graph. So label your x-axis, minutes. Your y-axis is the degrees, the temperature. I would go like we did before, 0, skip line 1, 2, and you could go up by 2s on this side, and then plot. So you should have a graph that looks like this. Your intervals may be different, but you still should have a straight line to see that this is a proportional relationship. So let's look at this one. It says Ray earned $15 per hour pet sitting plus a $5 travel charge. So we're going to use this function, A equals 15 times the number of hours plus 5, to track his earnings, where A is representing the amount he earns and H is the number of hours. So I'm going to plug in H and A, and we're going to plug in the numbers 1, 2, 3, 4. We're not going to graph this one. So what I want you to do is plug in what's your input and get your output, and then see if the ratios are the same. So you should have gotten 20, 35, 50, and 65. Set them all up as a ratio, and you would see that this is not a proportional relationship because they are not the same ratios. Going back to the last two slides, you always want to check to make sure that the ratios are equal, because you will always graph a line, but that doesn't mean that the relationship is proportional. So we want to simplify, and that will help us to see that yes, this graph is proportional. Going back to the first example, putting 1 over 12, 2 to 24 simplifies to 1 to 12, 3 to 36 simplifies to 1 to 12, and the same with 4 to 48. So you always want to check that the ratios are proportional, even though the graph looks like a line. So that's it for this lesson. Tomorrow we're going to do an activity, so it's very important that you bring any questions you may have. For tonight, the quiz is going to be on the video, so you will not need to go to Google Docs. The quiz are the next 5 slides. So you want to tell me if the relationships are proportional. So the answers and your work need to be in this file. So this is quiz question number 1. Quiz question number 2, is the relationship proportional? Quiz question number 3, is the relationship proportional? Quiz question number 4, is the relationship proportional? And quiz question number 5, is this relationship proportional? Bring any questions you have to class tomorrow, and have a great night.